Hey guys, this is a step-by-step guide to paper 1-2 of the May June 2020 IGCSE and math paper. So let's get started. Question 1. On the axis below, sketch the graph showing the coordinates of the points where the curve meets the axis. Okay, so we have the equation from the question, and we know that this is a cubic graph. And from this equation, we can also tell the x-intercept, which will be x equals to 2, x equals to -1, and x equals to -2. So we can kind of plot this on the graph. -1, -2, and then 2. Okay, since it's a positive x cubed graph, the shape will look roughly like this. And okay, I'm just going to draw it out to show. Since the cubic graph will look roughly like this, but because there's a modulus sign in this question, we have to reflect the part that is underneath the x-axis on top. So basically reflecting the x-axis. So it will be, this part will be reflected, and then this part will also be reflected. So we can just erase this part. Okay, so the y-intercept will be 4 because you take -2 multiplied by 1 multiplied by 2, which will give you -4, but because it's a modulus, it will just be 4. Okay, question 2. The volume of a sphere of radius r is given by this. The radius of a sphere is increasing at the rate of 0.5 cm per second. Find in terms of pi the rate of change of the volume of the sphere when r is equal to 0.25. Okay, so we're finding the rate of change of volume. So this will be dv over dt. And then from the question, we also know that the radius of the sphere is increasing at this rate. So this will be dr over dt is equal to 0.5. And then we can create an equation from these two. So dv over dt is equal to dv over dr times dr over dt. And then we can find dv over dr by differentiating this equation. So when we differentiate, we'll get 4 pi r squared. And since we know that r is equal to 0.25, we can sub r into this to find the actual dv over dr value. So this should give us 0.25 pi. Okay, now we have dv over dr and dr over dt. So we can use this equation to find dv over dt. Okay, since the question wants the answer in terms of pi, we can just leave it like this. Question 3. Find the first 3 terms in this expansion in ascending powers of x. Give each term in its simplest form. Okay, so to start with, we can write the expansion by taking the power on top, which is 6. Okay, so the second value will be 4. And then the third value would be minus 6 over 16, minus x over 16. Okay, so the question wants the first three terms in ascending powers of x. So that means the minus x over 16 must first be 0. Therefore, the power will be 0, so that it wouldn't give us an x value. And when the power of here is 0, the power of 4 will be 6, because both of the powers must add up to be the same as this value. Okay, so when the third term, the power, is 0, then the value on the first one will be 0 as well, because these two values must be the same. This value and this value, they both must be the same. Okay, so we can repeat this for the next term. Okay, so this value will be 1 because from the first to the second, this will always be increasing. And when this is 1, this power will be 1 because these two will be the same. And this power will be 5 because both of the powers must add up to be 6. Okay, and then using the same method, we can find the third one. Okay, now we just find the value. So 6c0 times 4 to the power of 6 times 1. Okay, so we can type 6c0 times 4 to the power of 6 into the calculator, or you can just type 4 to the power of 6 because 6c0 is 1. And then you should get 4096. And then 6c1 times 4 to the power of 5 multiplied by this. Okay, so now we have the first three terms. We can rewrite this expansion. So this is the final answer. Part B, hence find the term independent of x in the expansion. Okay, so for this question, we should firstly expand this part, because we already have the first three terms in the expansion of the first part from part A. So we should get this answer. And then now we need to think about which combination of these two values, all of these values, will be multiplied by one another to get a term independent of x in the expansion. Okay, so let me write this so that it's easier to explain. Because for this expansion, we have 4096 minus 384x plus 15x squared. And then for this one, we already found it from this part, so I'm just going to write it. Okay, so these two are multiplied by each other, and we need to think which combination of these values multiplied by one another will get a term independent of x in the expansion. So for example, 4096 multiplied by minus 2 will give an answer that does not have x, which is minus 8192. And then we also have 15x squared multiplied by 1 over x squared, which will cancel out the x squared to give 15. So we have these two values which will give the term independent of x. So we just add them up. And this is the answer. Part 4. Find how many different 5-digit numbers can be formed using these digits if each digit may be used only once in any number. Okay, so we have 6 digits. We have 6 digits. And there's only 5 slots available because it has to be a 5-digit number. Therefore, it will be 6p5. Because the order of the numbers matter since we are finding numbers. So it will be permutation and not combination. So it will be 720. Part 2. Find how many of the numbers found in part 1 are not divisible by 5. Okay, so to find this, it's easier to find the numbers that are divisible by 5 and then subtract that from the total possible numbers that can be formed. Okay, so to find the numbers that are divisible by 5, the number must end with 5 or 0. But because 0 is not in the numbers listed here, we can just consider 5. Okay, so we have a 5-digit number, and the last digit must be 5. So this will be 1p1. And then for the rest of the slots, it will be 5p4. Because there's only 5 numbers left after using 5, and we need to fill in 4 slots. So this will give 120. And then we take the total possible numbers that can be formed using, which is like found in part 1, which is 120, and then minus 120. And then we will get 600. Part 3. How many of the numbers found in part 1 are even and greater than 30,000? Okay, so for this question, there's 2 requirements. A number has to be even and it has to be greater than 30,000. So once again, we have a 5-digit number, and for it to be greater than 30,000, it can start with 3, 5, 7, or 8. And for the number to be even, it must end with an even number, which can only be 2 or 8. Okay, so the numbers that repeat will be 8. So we must only consider it once. So let's consider the numbers that don't repeat first, which will be 3, 5, 7, and 2. So for the first slot, it will be 3p1 because there's 3 possible numbers that can fill in this slot. And then the last one will be 2p1 because it can be 3 and 2 or 3 and 8. And then the other numbers will be anything. So we used up 2 numbers already, so there's only 4 numbers left from the 6 numbers. So it will be 6p3 because there's 3 slots left. Wait, sorry, it'll be 4p3. Okay, now we are considering the 8 that repeats. So it will be 1p1 times 1p1 and then times 4p3. Because for this 8, it can only be 8 in the first one and then 2 in the last slot, because 8 cannot repeat in this number since the digit may only be used once. So this will give us 24. And then we add these two up. And this is the total numbers that can be formed. Part B. The number of combinations of n items taken 3 at a time is 6 times the number of combinations of n items taken 2 at a time. Find the value of the constant n. Okay, so we can form an equation from this question to find the n value. So the first part of the question is this. So this would be NC3 is equal to 6 NC2. Because NC3 is 6 times of NC2, so NC3 is 6 of NC2. So we can just write this equation. And then we can use the NCR formula, which will be n factorial divided by r factorial multiplied by n minus r factorial. Okay, so we can just use this equation. So r will be 3, so 3 times 2 times 1 times n minus 3 factorial is equals to 6 n factorial, r factorial, which would be 2 times 1, and then n minus 2 factorial. Okay, so we can cross multiply. Actually, it's kind of easier to do it like this so that we can cancel out. We can cancel 2n factorial to n factorial. And then we're left with this. And then n minus 2 factorial is same as n minus 2, n minus 3, blah blah blah. And then 6, n minus 3, n minus 4, blah blah blah. So we can cancel this out. And n will equal to 20. Question 5. Find the range of f. And we are given the function for x is larger than 0. Okay, so for this kind of question, it will be easier to know, easier to do if we know how the graph looks like. So a normal x squared graph will look like this. And from the equation, we know that plus 3 means that the graph shifts to the left by 3. And if you're not sure why, I suggest looking into graph transformation for quadratics. Okay, so the graph will shift to the left by 3, so it will look like this. And then the y-intercept will be 3. And x will be minus 3. Okay, so from the 2x, we know that the graph will be stretched by scale factor a half, but we don't really need this because we know that the graph roughly looks like this and the question only wants x larger than 0. The range, let me draw this again. The range, which is the y value, can only be larger than the y-intercept, and the y-intercept is here. So we only really want this part of the graph. So we just sub 0 into fx to get 9, which is the y-intercept. Okay, so when we sub, we will get 9. So this is the y-intercept. Therefore, the range is f is larger than 9. And this is not larger than or equal to because the question only has the sign for larger than, and there's no equal to. Okay, part B. Explain why f has an inverse. So f has an inverse because f is a one-to-one function due to its domain. And normally a quadratic graph will be a many-to-one function, but because the domain of this function limits it, it becomes a one-to-one function. So it is a one-to-one function. And you have to say because of its domain. Okay, part C, find the inverse of f. So the equation is y equals to x plus 3. This is from the question. And to find the inverse, you have to switch the x and y around. And you should get x is equal to 2y plus 3 squared. Then you rearrange to make y the subject. So square root of x is plus minus, and then 2y plus 3. So y will be minus 3 plus minus root x over 2. So y can be minus 3 plus root x over 2, or minus 3 minus root x over 2. But the inverse of f can only be minus 3 plus root x over 2. It can't be the negative root x because x has to be larger than 0, which is the domain here. So this is rejected. Rejected because x has to be larger than 0. Part D, state the domain of the inverse of f. Okay, so the domain of an inverse function is the range of the original function. And we know the range is f is larger than 9 from part A. Therefore, the domain will be x is larger than 9. Part E, given that gx is ln x plus 4 for x is larger than 0, find the exact solution of fgx is equal to 49. Okay, so we know fx is equal to 2x plus 3 squared. And then gx is in the question. We just sub gx into the x value of fx, and that is equal to 49. Okay, so the square root of 49 can be plus 7 or minus 7. Now we just rearrange the equation. The inverse of ln will be e to the power of 2. Okay, so this answer is rejected because x has to be larger than 0. And if you type this into the calculator, it's actually a negative value. Okay, so you have to clearly reject this answer. And this will be the only answer. Question 6. The diagram shows the straight line and part of the curve. The straight line intersects the x-axis at the point A and intersects the curve at the point B. The point C lies on the curve. The point D has coordinates 1, 0. The line CD is parallel to the y-axis. Okay, so A is where the equation 2x plus y equal to minus 5 crosses the x-axis. So y is equal to 0. So we don't know the x value, but we know y is equal to 0. So we can just sub y equal to 0 into this equation to find the x value. Okay, so the coordinate of A will be minus 5 over 2, 0. And then B is where the line meets the curve, so we can rewrite both equations to make y the subject and then equate them to find the x coordinate of B. Okay, so I'm going to rewrite the equation of the line. And then the equation of the curve will be minus 3 over x. And then we can equate both of these. Okay, now we have a quadratic. Wait, sorry. Minus 5. This is minus 5x. Okay, so now we have a quadratic. We can put this into the quadratic equation to get x is equal to half and x is equal to minus 3. You can also factorize this. And then the x value for B must be a half, because minus 3 would be in the negative quadrant, but because B in this diagram is in the positive quadrant, so it must be half. And then now we have to find the y value for B by subbing a half into one of these equations. And I'm going to use minus 3 over x. Then y will be minus 6. So we have the B coordinate now. Part B. Find the area of the shaded region, giving your answer in the form where P and Q are positive integers. Okay, so we have the shaded region already, and we can actually split the shaded region into a triangle and another section. Okay, so we need to find the C coordinate, but let me just write the B coordinates. Okay, so we know that CD is parallel to the y-axis, so it's a straight line. And the x coordinate of C must be 1, because D is like directly above it, and the x coordinate of D is 1. Okay, and then C lies on the curve xy plus 3 equal to 0, so we can just sub y into this, and we should actually get, we need to sub 1 into this equation to get the y value. So we should get minus 3 as the y value for C. And let me just write down the working. So to find C, we use y is equal to minus 3x, where x is 1. So the y value will be minus 3. So coordinate of C will be 1 minus 3. Okay, so now we can integrate the equation of this line between minus 5/2 and a half. So integrating this will get the area of this triangle. So half minus 5/2. So we'll always put the larger value on top. And then the equation is minus 5 minus 2x. Okay, so integrating minus 5 will give minus 5x. And then minus 2x will give minus 2x squared, because you add 1 to the power. And then divided by 2, because you divide by the power. And then now we sub half and minus 5/2 into this equation. And typing into the calculator, you'll get minus 9. And then this should be the value of the area, but it's negative because it's actually under the x-axis. So just take minus 9 as positive because area can't be negative. So the area of that part will be 9. Okay, now we integrate the other section, which is this part. We will have to integrate the curve xy plus 3 equal to 0 between a half and 1. So the larger value will go on top, and it will be 1.5. And then the equation of the curve is minus 3/x. Okay, so integrating this will give minus 3 ln x. And then now we sub 1.5 into this equation. Okay, so minus 3 ln 1 is 0. And then we have minus minus, which will be plus 3 ln.5. And we can bring 3 to make it half to the power of 3, which will be ln 1/8, which can also be rewritten as 2 to the power of minus 3. And then you bring this back to get minus 3 ln/2. But an alternative way would be 3 ln to the power of minus 1. And then you bring the power back to get minus 3 ln 2. Okay, so this is the area of the section. And because area can't be negative, you just take minus 3 ln 2 as 3 ln 2. So the area of this section is 3 ln 2. And then since we want the area of this triangle and this section, we just add 9 and 3 ln 2 to get the final area of the shaded region. So the final answer is this. Question 7. Given that this, show that the differentiation is this, where a, b, and c are integers. Okay, so we can use product rule because there's two terms multiplied. We can let u is equal to x squared minus 1 and v is equal to 5x plus 2, and this whole thing is root. So we will differentiate both of these. And then we can rewrite this. And now we can use the power rule to differentiate this. And then we let u is equal to the term inside, and then y is equal to u to the power over half. And then we differentiate this again. Okay, so we plug this into the equation, which is dy du times du dx, which will be half u is 5x plus 2, the power of minus half, times du dx, which is 5. Okay, so now we have the differentiated values for u and v. We can use the equation for the product rule. v du dx plus u dv dx. Okay, so this value should be dv dx. Okay, so the first part is 2x times v, which is and then u times dv dx. And then now we can just rearrange this. Okay, so from this to this, it becomes a fraction because of the negative in the power, and then the half value of the power is the square root, so it's actually square root 5x plus 2, and the whole thing is 2 power of negative 1, which is 1 over square root 5x plus 2. Okay, so the question has this denominator, which we already have in the second term. So we can just make both of the values have the same denominator by multiplying. Okay, so 2x times 2, and then root 5x plus 2 times root 5x plus 2 will remove the square root to get 5x plus 2. And now both of these terms have the same denominator. So this is the answer, and it's written in the form that is required in the question. Part B. Find the coordinates of the stationary point of the curve where x is larger than 0. Give each coordinate correct to two significant figures. Okay, so I'm going to rewrite the dy dx equation from part A so that it's easier to refer to. Okay, so to find the coordinates of the stationary point, we know that dy dx is equal to 0 at stationary point. So this equation should be equal to 0. Okay, so when we multiply the denominator by 0, it will just be 0. So we have this quadratic, which is equal to 0. And then we can use the quadratic equation to get the x values. And if you type this into the calculator, you should get 0.31 or minus 0.63. And the x value has to be larger than 0, so this value is rejected because x has to be larger than 0. And then for this x value, we have to find the y value since the question wants the coordinate. To find the y value, we just sub it into this equation. And you should get minus 1.7. So the coordinate of this stationary point should be 0.31 and minus 1.7. Remember to give the answer in two significant figures as stated in this question. Okay, so this is the final answer. Part C. Determine the nature of this stationary point. Okay, so for this section, there's two ways that we can find the nature of a stationary point. And the first way is to find the second derivative of this equation. And then we just sub 0.31 to get the d squared to get the d squared y dx squared value. Okay, so you can use the quotient rule for this since we're differentiating the first derivative. Okay, so this is the dy dx equation, which is kind of long, but I'm just going to sub x is equal to 0.31 into this equation and just type it into the calculator, and I'll get the dy dx value, which is 6.258. So when x is equal to 0.31, dy dx is equal to 6.258. Sorry, this should be the second derivative. So when this is larger than 0, the point 0.31 minus 1.7 is a minimum. Okay, so this is the first way we can determine the nature. The second way we can do this is by considering the gradient on either side of the stationary point. For a cubic graph, the maximum will have an increasing gradient and then a decreasing gradient. So for the max, the gradient will increase then decrease. And then for the minimum point, it will decrease first and then only increase. So keep this in mind. And since the stationary point for this question is 0.31 minus 1.7, we can find the gradient of the points before 0.31 and after 0.31. So for the points before 0.31, it will be less than 0.31. So I can take x is equal to 0.1 and then find the dy dx, which will be minus 1.25. And then to find the points as like after 0.31, I can take 0.5, just any value that is more than 0.31. And the gradient will be 1.24. So the gradient on the left is minus 1.25, but the gradient on the right is 1.24. So the gradient is actually decreasing then increasing. So this shows that 0.31 and minus 1.7, this coordinate is the minimum point. And this proves our first way is actually correct as well. So let me just write an explanation. The gradient towards left is decreasing, and gradient towards right is increasing, which proves that it is a minimum point. Okay, question 8. The diagram shows the triangle OAB such that OA is equal to A, OB is equal to B. The point P lies on OA such that OP is equal to 3/4 of OA. So if OP is 3/4 of OA, OP is 3/4 of A, because OA is A, so this will be 1/4 A. The point Q is the midpoint of AB, half of AB. The lines OB and PQ are extended to meet at point R. Find in terms of A and B, AB. Okay, so AB, we can just go AO plus OB, and AO is minus A plus B. Part B, find PQ, give your answer in its simplest form. Okay, so we can go PA plus AQ. And PA is 1/4A. AQ is half of AB, and we have AB from part A. It is given that this and this, where n and k are positive constants. Part C. Find QR in terms of n, a, and b. Okay, so we know QR is equal to n, which is a constant, of PQ. And we have PQ from part B, so we can just sub this in. Part D, find QR in terms of K, A, and B. Okay, so since the answer has to be in terms of K, we need to use BR since we know BR is equal to KB. So we can go QB and then BR. QB is half of AB. And yeah, we have the value from the previous question. And then BR is KB. Part C, hence find the value of n and of k. So we already have two equations for QR from part C and D. So we can just equate these two equations and then solve to find the values. Okay, so the A part and the B part will be equal. So minus 4 and A is equal to minus half A, and half and B is equal to half plus KB. Then we can just cancel out A and then rearrange to get n, which is 2. And for this one, cancel out B. And we already have the n value. Then k is equal to a half. Part 9. A particle P moves in a straight line such that its displacement from a fixed point O at time t is given by this. So this is the displacement equation. And since we already have the displacement equation, we can differentiate to get the equation of the speed. So differentiate. Okay, so differentiating sign will give cos. So 10 cos 2t, and then multiply by the value the differentiation of the value inside. So differentiating 2t, we get 2, so we multiply by 2. And then just simplify. So the equation of the speed is 20 cos 2t. And we want speed when t is equal to pi. So we just sub this in. And then it should be 20 meter per second. And for this question, remember to change your calculator to radian mode. If not, you'll get a different answer if you're in degrees. Okay, part 2. Find the value of t for which p is first at rest. So for p to be at rest, its velocity must be equal to 0. So the equation of the velocity is equal to 0. And then inverse of cos we'll get pi over 2, and then t is equal to pi over 4. And by the way, since we are finding the value when p is first at rest, we can just use the first inverse cos value. Part 3, find the acceleration of p when it is first at rest. Okay, once again, we can differentiate the velocity equation to get the equation of the acceleration. So dv or dt. And differentiating cos will give minus sign, so minus 20 sine 2t. And then we have to multiply by the differentiation of the equation of the value inside, so 2. Minus 40 sine 2t. This is the equation for the acceleration. Okay, now we know that from part 2, when t is equal to pi over 4 is when p is first at rest. And the question wants the acceleration when p is first at rest. So we just sub pi over 4 into this equation. And we should get minus 40 meters per second squared, because this is acceleration. Part B, the diagram shows the velocity time graph for a particle q traveling in a straight line with velocity at time t. The particle accelerates at 3.5 meters per second squared for the first 10 seconds of its motion. Okay, so here its acceleration is 3.5 meters per second squared. And then the particle travels at a constant velocity v for 10 seconds. The particle then decelerates at a constant rate and comes to rest. The distance traveled during the interval 20 to 25 seconds is 112.5. Find the value of v. Okay, so the acceleration in the first 10 seconds is 3.5, and this is the gradient of the graph, because for velocity time graph, the gradient is the acceleration. So we can form an equation using this information. So basically, we are finding the gradient of this graph, and we have two coordinates, 0, 0, and 10, v. We want to find v. So to find the gradient, we just go, this is equal to 3.5. So v over 10 is equal to 3.5, and v is 35. Part B, find the velocity of q when t is equal to 25. So the distance traveled between 20 and 25 seconds is 112.5 meters, as stated in the question. And for a velocity time graph, the distance is the area under the graph. So we can form another equation. Basically, we are finding the area under the graph. Okay, so let's take the velocity at 25 seconds to be q. And then this part will be 5 seconds. So the area of the little rectangle is 5q, and then the triangle will be base times height, which is 5 minus q, and then times a half. And this is equal to 112.5. Okay, so we can rearrange. So q is equal to 10. And this is the velocity of q when t is equal to 25. So the velocity is 10 meter per second. Part 3. Find the value of t when q comes to rest. So we are finding this value. And because we don't really have much information, we can find the deceleration of q between 20 and 25. And this should also be the gradient, which is this part. Because this value will be the same as the deceleration between 25 to rest, which would be this part also. Because the gradient is the same for this whole time period. Okay, so let's find the gradient of the graph between 20 and 25. So we have two coordinates, 20 v, and v is 35. And then we have 25 q, which is 10. And then we just find the gradient, which will be minus 5. Okay, now we have the gradient of the, which is the deceleration. We can find between 25 and when it's at rest. So it'll be 25 q, which is 10, and then t, which is what we're finding, and then 0, because the velocity is 0 is because the particle is already at rest. Okay, so 0 minus 10, t minus 25. And this is equal to minus 5. And t is equal to 27 seconds. Part 10. Solve tan 3x minus 1 for this, giving our answer in terms of pi. Okay, so because the value is negative, we know that we'll be finding angles that tan is negative in, which is the second and the fourth quadrant. And we can use this. Add sugar to coffee, and then tan is positive in these two, and it's negative in the second and fourth quadrant. Okay, so the inverse of positive 1, pi over 4. And then we want to find the angle in the second and fourth quadrant, which will be pi minus pi over 4 and 2 pi minus pi over 4. And so 3x will be pi minus pi over 4, 2 pi minus pi over 4. Okay, so 3 pi over 4 will be divided by 3, which will give pi over 4. And then we take 2 pi minus pi over 4 divided by 3 to get 7 pi over 12. Okay, so this is for the fourth quadrant. And then we repeat for the negative values where we go clockwise. So in the negative quadrant, we have the base angle, which is pi over 4. But since it's negative quadrant, it will be minus pi over 4. And then you just divide by 3 to get minus pi over 12. And this is in the fourth quadrant. And tan is also negative in the first quadrant. So we will take pi plus pi over 4, and this whole thing is negative since it's in the negative quadrants. And then we have this whole thing divided by 3 to get minus 5 pi over 12. Okay, so we have this range in the question, and 7 pi over 12 is not in the range, so we will only have 3 answers, which is the remaining 3. Okay, part B. Use your answers to part A to sketch the graph for this range on the axis below. Show the coordinates of the points where the curve meets the axis. So if we rearrange part A, we'll get tan 3x plus 1 is equal to 0. And then we will multiply by 4 to get 4 tan 3x plus 4 is equal to 0. Okay, so this means that the y-intercept of the tan graph becomes 4 since it's multiplied by 4. Okay, since the x-intercepts don't change, pi over 4 is the x-intercept, and then minus pi over 12. And then also minus 5 pi over 12, which is here. So this is where the tan graph crosses the x-axis. Okay, so if you sub 2 pi over 12 into this equation, you should get an error because it means that it's a line of asymptote at 2 pi over 12. So we can draw this dotted line to show that this is the line of asymptote. And then you can repeat for pi over 2, which is here. This is another line of asymptote. And then minus pi over 12. And then minus pi over 2. This is the other line of asymptote. And these will all give you error when you sub it into this equation. So now we can draw the tan graph through the x-intercepts. And it's always going to gradually get closer to the asymptote, but it will never touch the asymptote. Okay, so this part should actually just like go straight up. Okay, we also know that the y-intercept is 4, so make sure it crosses 4. Okay, sorry, but this should actually like cross minus 5 pi over 12. And then we have the last part. Okay, so that's it for this paper. Thank you for watching, and I hope this video was helpful.